This is the second part of lesson number 13. This is 13.2, and we're on example 13.3. And we have an x plus y equals 20. And we have a 5x plus 10y equals 150. Okay, we're going to add those two, or we're going to use substitution in order to solve. So again, we're going to look for the simplest equation and set equal to something. So let's set it equal to x this time. So let's take the x plus y and set it equal to x. So I'm going to put that there, and I'm going to bring the y over here. And now I've got x equals negative y plus 20. So now in the second equation, wherever I see an x, I'm going to put negative y plus 20 in its place. So if we go back up there to the top, I've got negative 5 times negative y plus 20 plus 10y, this is the second equation, remember, equals 150. Use my distributive. Okay, combine what I can. So I'm going to combine those two. And negative 5y plus 10y is 5y. Subtract 100 from both sides. Again, this is probably just old hat for you. Divide by 5, y equals 10 for this one. So if y equals 10, now we're going to take this and we're going to put it back into one of our original, which I would pick again the easiest one. So we have x plus y equals 20, and we're going to put 10 in, 10 in for y. So x equals 10. So my answer then is going to be my x value and my y value, 10, 10. And I'm done with that. All right, so section 13b. And this section is called area of an isosceles triangle. So if you remember an isosceles triangle, and this is example 13.4, an isosceles triangle has two of the sides that are the same length. And if two of the sides are the same length, where they connect to the base are the same degree measurement. Okay, which the degree measurement at this point doesn't matter, but later on it will. And what they're interested in doing for 13.4 is finding the area of this triangle. Well, you know that the area of any triangle is 1/2 BH. Well, 5 is not the height. 5 is the slant height, and we're not interested in that. We're interested in, and let me get a better color here, like black. We're interested in the height from the highest point of the triangle, 90 degrees down to the base. That is what we're interested in. That's the height. Well, how do we do that? Well, we're going to have to use Pythagorean. And Pythagorean says that one of the lengths squared plus another length squared equals the hypotenuse squared. So what we're going to do is we're going to look at one of these triangles right here. We're going to look at this one. And that says that the height, which we're going to call A, this right here, we're going to call that the height right here. So let's call it A instead of H. And we'll call this B, and this will be our C. Alright, so we don't know the height, that's what we're looking for. But we do know this length from here to here, because it's going to be half this 4. So that's going to be 2 squared, and my hypotenuse is 5 squared. So I do the math, and I continue going, and I get 25 minus 4. So a squared equals 21. Or a equals the square root of 21, because remember, to get rid of an exponent of 2, I take the square root of both sides. So I get the square root of 21. So that ends up being my height. So again, area is 1/2 base times height. So area equals 1/2 the length of my base, and the length of my base is going to be 4, because we're looking at the area of the entire triangle, not just this part. We use just this part to find the height, to use Pythagorean, but to find the area of the whole thing, we have to use the length of the base, which is 4, times the height, which we found to be the square root of 21. Okay, so then we take half of 4, so that's 2 times the square root of 21. Well, we can't reduce the square root of 21 at all, so that ends up being our answer as far as the area is concerned. So you can take a calculator out and find the square root of 21 and get some number somewhere between 4 and 5, multiply that by 2, and it'll give you an area that is workable. The square root of 22 doesn't really help you. I mean, how big is that anyway? So that's finding the area of an isosceles triangle. First of all, you have to find the height, and that's probably what the struggle was in this lesson, is first of all finding the height using Pythagorean, and then taking 1/2 base times height. Okay, so that's it for lesson 13.